Welcome to my projectbazaar.com. Now we discuss about the product feature-based image patch approximation for lung tissue classification. In this paper we propose a new classification method for classifying 5 categories of lung tissues in high resolution computer tomography images with feature-based image patch approximation. We designed two new features for namely local binary pattern and multi-coordinate histogram of oriented gradients descriptor. Together with the intensity feature, each image patch is then labeled based on feature approximation from reference image patches. A new patch adaptive sparse approximation method is designed with the following main components: minimum criteria for sparse based classification, patch specific adaptation for approximation. The patch-wise labeling are then accumulated a probabilistic estimation for region-level classification. The proposed method is evaluated on the publicly available database that showing encouraging performance improvements over the state of arts. And finally, this method proposes the better result and achieving the better performance. At first we took an input image from the dataset. Then the pre-processing step is undertaken. In that pre-processing we apply the Weiner filter to filter the noise from the image. After the noise filtering process, we extract the feature from the image. There are two features, namely RGLBP feature extraction algorithm and the MCHOG feature extraction algorithm. The LBP feature extraction is the feature extraction method which is used for extracting the feature from the image. The extracting feature is nothing but the texture feature, and then the MCHOG feature is a feature extraction method which is used to extract the feature like gridded feature from the image. After extracting the features from the image, the classification process is undertaken. The classification is done using the SVM classifier. The SVM classifier is abbreviated as a support vector machine. After the classification result, the category of the lung tissue is shown as the text. On the other hand, the type of the tissue is represented as the text format. Now we see the initial running procedure for the process. Now right click on the main.m file, then select the third option, run. Now the guide window was opened. We can see the 5 push buttons in that window: load image, pre-process, LBP feature extraction, Gabor feature extraction and HOG feature extraction. If you click the load image button, one dialog box is opened like this. In that one we can see the test crop folder. If you select that one, we can see the 20 images in that folder, and then select any one image from that folder. After selecting that image, we can see the two things. One thing is, first the initial image, that is query image, is shown in the axis. Then the histogram of the input image is also shown in figure 1. Then after clicking the pre-processing, the filtering is applied for the input image. After applying the filtered image will shown in the axis 2. Then the LBP feature is extracted for the pre-processed image. After clicking the button LBP feature, we can see two things, like one thing is figure 1 that shows the LBP image with the feature extraction. Then the feature extraction values are shown in the table. This table is represented as an UI table. Then the Gabor filter is applied for the another feature extraction method. The Gabor filter gives the 12 filtering iterations for a single image. After getting the Gabor filter, we can again get some feature values like this. Then HOG feature is extracted for the process. After clicking the button HOG feature, another GUI window open in simultaneously. Then you can see the HOG feature extraction button in that GUI. After clicking that HOG feature extraction, we can see the input image and the HOG features. In left side we can see the filtered image, and simultaneously in the right side we can see the HOG features which is extracted from the image. Then click the next button to get the another GUI window. In that window we can extract the total features, like that they combine the LBP Gaber and HOG features. By clicking that extract feature button, we can see the whole features which is extracted from the image. After extracting the feature from the image, the feature values are shown in the table. Then click the next button. Now several figures are several tables are represented in the GUI window. Then click the train features. These are the train features for each and every images up to 8th image. Okay. Now we can see the each and every features for the separate images up to 8th images. Then the remaining features are shown in the next page. After clicking the next button, we can see the GUI window with two buttons, classify and graph. Now click the button classify. Then the classified output was shown in as the text format. This is the edit box, the text which is shown in the edit box. Now click the graph button. Now the graph GUI is opened. In graph GUI we can calculate the three things. First one is recall, then precision, then F-score. By clicking the button graph, we can see the three different kinds of graphs. With the line graph, we can see the precision, recall and F-score. For that, these three things are shown in the single GUI window.